Well, a very good day to all of you. Welcome to this session on TBO, and in particular, what the Asia Pacific region is doing with TBO. TBO has been branded as a major transformation for aviation. TBO has promised to improve traffic flow management, optimize airspace capacity, reduce CO2 emissions, enhance safety. This sounds almost too marvelous to be true, and we cannot wait to jump on this magic carpet. But where is Asia Pacific in this transformational development? And how do we get started? In a way, the Asia Pacific has already started on this journey, and that's why we're having this session. Let me set the context. To fully appreciate the paradigm shift in TBO, we need to understand the situation today. Today, no single player in the air transport system has the full picture. For instance, a flight dispatcher prepares a flight plan, pre-flight, and disseminates it. But this flight plan is not necessarily followed or continually updated. When the aircraft is in the air, the link between ATC and the flight deck is mainly by voice, or even if it's by data link, changes in flight due to weather or military activities are not captured. Hence, this flight is not optimized for downstream flight planning. This is further complicated by the fact that the aircraft transitions through various ANSPs who do not talk a lot to each other. To put it simply, it is a fragmented air transport system. But you can do a lot better. The key for the future is complete information throughout the life cycle of a flight, from gate to gate. All the players will operate from the same updated plan. The dimension of time will be included. In addition, there will be the application of collaborative decision making throughout the trajectory. Before we can realize the concept of TBO, a few technical enablers need to be ready. The current flight plan will not be able to handle the kind of dynamic information exchange in TBO. A new means for flight planning is being developed, and it's called Flight and Flow Information for Collaborative Environment, or FFIs for short. While TBO is the operational concept, FFIs is the main mechanism for making it happen. TBO and FFIs go hand in glove. To support this dynamic information exchange, we need the communication infrastructure and protocols. This is where another often heard acronym, SWIM, comes in, which stands for System-Wide Information Management. Is it too early for Asia Pacific to be preparing for TBO? FFIs was first formally adopted way back at the 2012 ICAO Air Navigation Conference. ICAO has already published guidance material on FFIs. Release 1 of FFIs for pre-departure planning and filing has already been completed. Release 2 for post-flight operation is currently being developed. Already a few ANSPs in the Asia Pacific have conducted a SWIM demonstrator way back in 2019. It showcased the enhancements achievable from a more efficient information exchange network. Right now, another demonstrator on TBO for the Asia Pacific is taking place. Is it too early for the Asia Pacific to be preparing for TBO? We learn best by doing. In the new approach to capability development, we may not be able to wait for all the pieces to be in place or a perfect solution before we start experimenting. The traditional line between producer and consumer is getting very fuzzy. In the technology world, the trend of prosumers is becoming more common. A prosumer is not just a passive consumer, but someone who is prepared to shape what the final product will be like. The best way to progress is to try something and correct ourselves along the way. If we look back in history, we should not forget that the Asia Pacific region has made wonderful progress in ATFM through an approach that is founded on information sharing and collaborative decision making. Does that sound familiar to you? This should give us confidence in approaching TBO and FFIs, working with other regional partners. We should leverage on this ready-made regional platform for exchange of ideas and collaborations. We can take a step-by-step approach to TBO. This afternoon, we have invited a panel of 4 speakers who have been intimately involved in the ongoing TBO demonstrator. They are Wei from CES, UQ from JCAB, Amor from Aerotime, and Diana from FAA. Before I invite the first speaker to address us, the team would like to screen a video that clearly explains what TBO is.
A little knowledge goes a long way, especially when that knowledge guides our decisions along the journey. That's the essence of the trajectory-based operations concept. In short, TBO is an air traffic management concept that enhances strategic planning under changing conditions, providing the information and capabilities to help expedite aircraft movement between origin and destination airports. TBO will shift from a voice-based set of exchanges between participants to an environment primarily involving data exchange between interoperable systems. See how TBO is shifting the decision-making paradigm, moving from a tactical approach to a more strategic one. Currently, tactical decisions are taken because some information is only available at the moment. These add up, and operators pay the price by loading more fuel. If we had greater access to the information, we could, and we would, make more strategic decisions ahead of time, instead of reactive course corrections. But by continuing to follow a tactical paradigm, we waste time and fuel. Imagine having access to the information you need, when you need it, and having it tailored to improve decision-making for your flight. Data exchange technology has caught up with this vision, and now we have the capabilities to make it happen. Through improved strategic planning and management of traffic flows, TBO will reduce reactive decision-making. This will increase predictability and efficiency, and optimize the ATM system. Aircraft trajectory is the core tenet of TBO. Defined in 4 dimensions: latitude, longitude, altitude, and time. The trajectory represents a common reference for where an aircraft is expected to be and when at key points along its route. The trajectory is defined prior to departure, updated in response to changing conditions, and shared between stakeholder systems. Here are the 3 key elements of TBO. Time-based management helps manage traffic flows and trajectories by scheduling and metering aircraft to better manage congestion. Performance-based navigation enables aircraft to more accurately navigate along their trajectories. When combined with decision support tools, predictability and compliance to schedules are improved. TBO is the use and exchange of better information across systems, capabilities, processes, and people, working together to improve the performance of air transportation. And that brings us to the next exciting phase of TBO, validation. Through a series of technical exercises with multi-regional partners, we're building on all the exciting work and bringing TBO to the next level. These exercises help determine if TBO flights can be negotiated in advance and can operate with minimal interference from departure to arrival. Additionally, they consider how TBO flights will mix with those users who are not. Regions do not operate the same, nor do they possess the same capabilities and technology. Our participating partners are developing capabilities that are extensible across regions to achieve global harmonization. We asked our partners to identify their individual gaps and helped fill them in through a series of small test scenarios. These checkpoints and initial opportunities give us a broader infrastructure to build from, working toward our future demonstration efforts. Because the more we collaborate, the stronger the TBO concept becomes, and ultimately, we can build a more efficient system that works for everyone. The capabilities are maturing, and we're committed to building the groundwork for trajectory-based operations. Follow our journey as we set out to improve strategic planning and management of air traffic, and see where knowledge can take us next.
So our first speaker this afternoon is Mr. Lim Te Wei. Mr. Lim Te Wei is an experienced area controller with CEAS. He's also qualified in search and rescue. He's currently with CEAS ATM Plans and Development Division. His area of focus is ATM initiatives that promote enhanced cross-boundary traffic flows and seamless ATM of the region. He's the operational lead for CEAS participation in this ongoing TBO demonstrator. Te Wei, the floor is yours.
Thank you, Mr. So, for the kind introduction. A very good morning, good afternoon, and a good evening to everyone, depending on where you are. So, as mentioned, my name is Te Wei, and I'm en route the area air traffic controller by training. I understand in the audience there might be a very diverse range, some who may know this subject very well, and some who are just starting out and would like to find out more. So to cater to all, I'll try to do my best to introduce the concept of TBO to all of you as clearly as I can. Next, please. So before I begin, I would like to extend my acknowledgement to FAA colleagues for their efforts to promote TBO through the multi-regional TBO demonstration project, as mentioned by Mr. So Potin earlier on. Okay, I think through this project, there's certainly a lot more that we can discover, especially on the operational benefits and values, as well as the TBO capabilities that can be potentially delivered to the region and to each and every stakeholder. So to understand better on TBO, let us also recap on these two documents that you see on the left. Okay, the first is the GAMOC, also known as the Global ATM Operational Concept document. Okay, it is a visionary document that is intended to guide the high-level implementation of CNS technology, the communications, navigations, and surveillance, as well as ATM technology, by providing a description of how the emerging and future air navigation systems should operate. Okay, the famous vision statement, I'm sure most of you will be very familiar with, okay, which is to achieve an interoperable global ATM system for all users during all phases of flight that meets the agreed levels of safety, provides for optimum economic operations, is environmentally sustainable, and meets national security requirements. Okay, the second document is the GAM, the Global Air Navigation Plan, okay, which is now issued on the web portal. So it is ICAO's highest air navigation strategic document, and the plan provides guidance to drive the evolution of the global air navigation system in line with the GAMOC. So the GAM guides the region and ANSP to harmonize their implementation plans towards handling future air traffic. Both the GAMOC and the GAM points towards the TBO as the ultimate goal in order to achieve sustainable aviation. Next slide, please. So let's look at the paradigm shift in air traffic control. So if you look back many years ago, perhaps 30 to 40 years back, okay, ATC operations were primarily based on procedural control. Okay, there was a time when surveillance technology and their use is not as prevalent. The mode of operation then involved the use of paper strips to mark out position reports of aircraft, and we estimate where the aircraft was located. Okay, and because of this, controllers will tend to keep aircraft far away from each other to ensure safe separation. Okay, moving on, and with the proliferation of surveillance technology, from radars to ground-based ADS-B, ADS-B sharing between ANSPs, and now we even have a space-based ADS-B. Okay, we have migrated to what is known today as surveillance-based control, where we are able to know exactly where the aircraft is at the moment. And moving forward, that's our aim, which is we want to move towards TBO. With widespread automation and enhanced information exchange, coupled together with more accurate prediction technology, we'll be able to move towards TBO, where we know where the aircraft will be. The main role of the controller then is to shape the trajectory of the aircraft based on active collaboration between all the stakeholders in the system. Okay, although there's a small caveat here that I must mention, is that although this knowledge of future position is based on prediction, this prediction is much more certain and has a higher degree of precision. So actually, having said all this, so what exactly is TBO? There are many good literatures and writings on what is TBO. Okay, I'm sure you can find it on Google. Okay, we do have a proposed definition here, and it's in the blue box as you've seen. So TBO is actually a new paradigm in which the flight trajectories are optimized on a transboundary basis. Okay, where ANSPs are able to collaborate with airspace users to make better decisions at various stages of flight. So I think this is also mentioned by Mr. So earlier on. So in TBO, airspace users will share information related to the flight trajectories with various stakeholders, okay, including the ANSPs, okay, all the way from origin to the destination airport. The aim is for airspace users to fly with minimal deviation from their pre-agreed optimum flight trajectory. Airspace users can also put forth several trajectory choices, and this can be negotiated between the parties. Okay, as a result, TBO will actually enable airlines to fly a more efficient route, minimize delays, and increase predictability. This will translate to fuel savings and promote sustainable aviation. Next slide, please. So as mentioned, there are three key elements of TBO. I'll just go through a bit in depth for these three elements. So the first is time-based management. Okay, so for this, it allows traffic flows and trajectories to be sequenced and arranged to better manage congestion. Okay, this will include accurate targeted time over control points, so that there can be a more precise execution of sequencing for the arrival. And the next is PBN, okay, also known as the performance-based navigation. PBN is important, okay, in that it ensures that the aircraft is able to navigate the planned trajectories as accurately as possible and with greater precision. Together with decision support tools, this would help to ensure predictability, ensuring schedules are adhered to in order to reduce uncertainty. So for example, now with RMP2 flight routes implementations, aircraft is able to make use of onboard supporting equipment to fly along a more precise flight path with a higher level of accuracy, and also have the ability to determine the aircraft position accurately and with integrity within a radius of 2 nautical miles. Okay, and lastly, also one of the very important factor, there is information exchange. So as you can see earlier here, what we have mentioned, okay, there are many actors, stakeholders are involved in this whole operation. The key thing is for information exchange between all these systems, capabilities, processes, and the people. Okay, all this will help to improve the performance of air navigation. Okay, for an example, as Mr. So also mentioned, okay, there's the use of FFI's capabilities, okay, which is being demonstrated currently in our multi-regional TBO, or as we like to call it, Mr. TBO project. Okay, so the other speakers may explain a bit more later, but in essence, FFIs allows advanced information and more formats of information to be exchanged between the ANSPs and the airspace users. Okay, this will allow for the shared view of a common trajectory, and in a collaborative environment, the most optimum trajectory can be negotiated. Next slide, please. Okay, so one of the core principles of TBO, okay, is also known as trajectory. Okay, so it allows all the stakeholders and actors in the system to use it as a common reference for where the aircraft is expected to be. And this is defined in the 4 dimensions, okay, namely latitude, longitude, altitude, and time. Okay, the trajectory is planned and defined way ahead of time, okay, before departure, and it is negotiable and able to change according to any form of disruptions, be it sudden weather formation, thunderstorm clouds, or even military areas being activated. And importantly, the trajectory is also shared in a timely manner, okay, among all the systems. Next slide, please. Okay, so in this diagram as adapted from ICAO, okay, with TPO, actually air traffic management will take into account the trajectory of an aircraft, okay, during all phases of flight, and help to manage the interaction of that trajectory with other form of trajectories or hazards to achieve the optimal system-wide outcome with minimum deviation from the user requested flight trajectory whenever possible. So as shown, the blue line, which is the grid trajectory, and the actual trajectory are actually maintained, but yet there's also a certain refined tolerance within the trajectory, which will allow for greater predictability. Okay, I'll explain more in the next slide. Next slide, please. Okay, so in this diagram, you can see, so the red color aircraft is the conflict aircraft, and there's a small purple weather cloud. Okay, so when there's a conflicted aircraft or weather elements that disrupts this flight path, various trajectory possibilities, you can see the lines, the A, B, C, D, E, being negotiated in real time between the SP user and the ANSPs. Okay, so they can either fly further out or turn further in or try to go through some weather. Okay, so these are all being negotiated in order to achieve the optimal outcome. So you can see eventually the flight trajectory delta D is being chosen in this case. Okay, in the top left corner, you see some balance. Okay, there will be a balance between the operation cost and the demand capacity balance. Okay, when these two targets are met, okay, and they are well balanced, then that's the most optimal trajectory that the aircraft can choose. So this shows that TPO does not only focus on a single component or a stakeholder to satisfy, but it takes into account the overall operating environment to seek the best outcome. And all this information exchange negotiation, all this is done through SWIM and FFIs, okay, which I also mentioned earlier on. Okay, so the SWIM system provides the network for the message exchange between all the systems, while FFIs allows for the exchange of messages between the various stakeholders and systems as well. Next slide, please. Okay, so these two diagrams actually highlight how we move forward from our current voice-centric environment to the future info-centric operations. The dotted purple lines represent voice communication, and the thick blue line signifies data exchange. As shown on the left, our current work processes rely significantly on the voice communication between the human participants. Okay, granted, certain workflows have improved with the introduction of data exchanges. So for example, the ATFN unit can send a calculated takeoff time directly to the flight ops center to be sent to the aircraft. Okay, however, most of the time, what happens is that ad hoc changes, okay, such as weather, I think that's one of the most unpredicted elements, okay, they're still communicated via voice. So if you note in the way the information flows, it is often singular, going from one party to the other and operating in silo. This voice communication exchange are often not digitized. So as such, the inputs are not fed into the supporting automation systems. Thus, the automation system is unable to support ATC operation as optimally as desired if they had all this information. So to the right, you can see, okay, in the future info-centric ATM, all the stakeholders and their systems will have access to the same shared plan and trajectories. Okay, there's constant information flow and timely exchanges between all parties. So voice coordination will become the exception rather than the rule, but each party work with the knowledge of each other's constraint and consideration through this shared plan and common trajectory. Next slide, please. Okay, to define the changes clearer, I've summarized some of the pointers in this table below. So fundamentally, we'll be moving from a paper and voice-based system with information often kept in silo to a database system, okay, in a highly digitized environment okay, where there's automated sharing of information among all the stakeholders. Okay, as mentioned earlier, today's information is often inconsistent or not always available to the automation system supporting decision making. Okay, so in future, similarly, all this information sharing will be automated between all the participants and across all the different systems as well. So currently, I think the common practice would be that every participant will make their own decisions and optimize the plan according to their requirements, thus leading to inefficiency in the whole system. In future, the decision support automation for both aircraft and the ANSPs will be referring to and using the same trajectory information for strategic planning as well as tactical decision making in a collaborative environment. And they can leverage on the enablers, okay, which you mentioned earlier, SWIM and FFIs, to provide the network or message exchange systems. Currently, ATM operations is still very much highly tactical by necessity. Aircraft often comes in jammed together during the gateways, uncoordinated, so they need to be vectored for sequencing purposes. Okay, this results in wasted fuel and causes flight inefficiency. So in the future, all this would have been taken into account during the strategic planning. Okay, and strategic decisions should reduce the need for tactical intervention, or even if there's a requirement, okay, there's a certain degree of tactical actions that can be considered within this strategic planning. Okay, the tactical interventions will at the same time also respect the strategic plans, which is to say it will not deviate too much from the strategic plans. Okay, so this shows that it does not mean that once the trajectory is planned, there's no changes expected. Due to certain uncertainties, like we mentioned, weather, military training areas, activities, there's still a degree of local deviation that's allowable. So with FFIs, aircraft can actually use, there's a trial service function which you use. Okay, that you can actually use to suss out any potential disruptions beforehand and the plan to optimize their flight ahead of time. Okay, so if an aircraft, let's say, coming in from an upstream is late, okay, this is constantly being updated into the system and made known to all the stakeholders, and ATC can actually start rearranging for a resequence. Okay, so in this way, you can see priorities can be managed and priorities given to flights that require it more. For example, maybe a flight on emergency. Okay. Lastly, as aircraft operators tend to optimize the operation due to uncertainties such as holding, bad weather, or they are not able to get their optimum flight level, they will often carry more fuel. So despite their best efforts to plan, at the end of the day, they are still very much subjected to the tactical interventions by ATC as the situation evolves. In future, with greater access to and the availability of more accurate trajectory predictions and automated information sharing, as well as synchronization between all the stakeholders, all these inefficiencies should be removed or reduced drastically. Next, please. So in summary, TBO helps to ensure consistency between the strategic management and tactical interventions by using a common view of the trajectory. This trajectory would have considered the various restrictions across the stakeholders, and through negotiation and coordination, help to shape a trajectory that is acceptable to all. And because of this consistency, stakeholders will have a greater predictability. With collaborative decision making, this will ultimately allow for safer and more efficient management of flight trajectories. It should be recognized that for TBO to work, actually it will require participation for more parties. Okay, with more people coming on board, we'll be able to work towards sustainable aviation and help our Mother Earth while still enabling human connections through flying. Of course, this should be done after COVID subsides. And with that, I hope all of us here have a good understanding of what TBO is, and I'll proceed to hand over to my other panelists who will explain more in detail later. Over to you, Mr. So. Thank you.
Thank you, Wei. Well, next up, our second speaker is Mr. Imada Yukio. Yukio is another experienced air traffic controller. He has spent 12 years at the Tokyo Area Control Center and 12 years at the Fukuoka Air Traffic Management Center, working on ATFM, airspace management system. He's currently the Special Assistant to the Director of ATC Division in the Japan Civil Aviation Bureau. His current area of focus is planning ATC operation for the future. Yuko, you have the floor.
Okay, thank you very much, Mr. Pu, for the kind introduction and giving me this valuable opportunity this time. My name is again Yukio Imada, and good morning, good afternoon, and good evening, everyone. I'm glad to be here with you today. And following the TBO overview by Mr. Dawei Rim, I'd like to present what TBO is like, especially from operational perspective. I'm participating in the TBO demonstration introduced in the video we just watched. The demonstration is essentially aligned with the ICAO TBO concept, which will be published in the near future. You can find the draft version of the concept, including operational scenarios, on the ICAO official website. The global TBO concept describes an ATM environment where the flight path is close to the user preferred flight path by reducing potential conflicts and resolving demand capacity imbalance earlier and more efficiently. In the environment, a four-dimensional flight trajectory would serve as a common reference for decision-making across all stakeholders. If you'd like to know more details, you simply use the links below of this slide, and you can easily reach these relevant documents. There is a link for the manual on FFIs as well. It's a very important manual for the TBO operations. So next slide, please. Before going on operational scenarios, let me talk about what will change between today's operation and the new operation in TBO environment, as Dawei mentioned. But in this, the previous presentation, it said that one of the key elements of the TBO is information exchange. In today's operation, information exchange is very limited with limited data content in the limited infrastructures. So we can use only disparate information across participants and automation systems. It ends up inconsistent and inaccurate trajectory predictions. I illustrated such a situation as figures at the bottom of this slide using different colors. You see the various colors in the current situation, green, the pink, and the blues, and the black, and the gray, and the white, and the blue again. So we are lacking, we are facing a lack of information sharing, not only between airspace users and ATM service providers, but even within ATM service provider systems in one ASP, and of course between ASPs across the FAIRs. So it means each actor uses and manages their own trajectory respectively, which is not shared among them. So some gaps exist during decision making. So in addition to that, major means for communication is now voice, as you can see the figure in the middle. So it's the figure is from the TBO concept scenarios. So it's a slightly different from the previous one that we presented. So it's not automated, of course, it's a voice. On the other hand, in the TBO environment, we use trajectory that is shared and managed as a common plan for the flight trajectory prior to departure and even during execution of the flight. So you can see the picture with one color green. So everybody has the agreed trajectory. So everybody watch and see and recognize the same trajectories. So this trajectory information is exchanged by the automated system. So it allows more accurate, consistent, and operationally relevant information to human actors, as shown in the figure on the right middle. It's a little bit small, sorry. So even in TBO environment, a human is a crucial factor, of course. So human in the loop is the circumstances even in the TBO environment. So it's very important interface to the system. So TBO looks like a long way to achieve, but the evolution towards TBO will occur with incremental approach. As mentioned earlier, this incremental approach is expected to align with the development of ASBU aviation system block upgrades in the GAMP, Global Air Navigation Plan. So next slide, please. Thank you. So now I would like to talk about operational images from pre-departure planning phase. These are from ICAO Global TBO concept operational scenarios. Prior to departure, the airspace user and ASP engaged in an information exchange for planning purposes as illustrated on the left. This information exchange process is consistent with the process of FFI's Release 1. EASP, you can see in the picture, EASP means ATM service provider that is capable of providing FFI services. Similarly, an EAU, you can see the picture into the picture, means airspace user that is capable of using FFI services. Firstly, ASP publishes the constraints, and an airspace users obtain the known constraints from the ASP together with additional information on the flight and the environment. For example, meteorological conditions or airspace, military airspace conditions, such as. Consistent with this information, the airspace user develops a proposal for a flight including the 4D trajectory. The plan is evaluated by the concept components of AOM, Airspace Organization and Management, DCB, Demand and Capacity Balancing, and AO, Air Operations. They check data from semantics and the syntax perspective and operational acceptability together with applicable constraints, which is conducted all ASPs concerned. You can see the picture. And in this case, from the FIRA ASPs until FIRC ASPs, including, of course, FIRB ASPs. So this agreed trajectory is very consistent and reliable, even before the pre-departure. So the airspace user is informed of any additional applicable constraints which may not have been included in the original constraint publication from the ASP, and the plan is received by the airspace users. Finally, a common and more accurate view of the agreed trajectory is shared among stakeholders concerned. That is the process of pre-departure. It will be realized by FFI's Release 1 process. Next slide, please. Thank you. So next, I introduce some of the scenarios in the pre-departure planning process from TBO demonstration briefly, not one by one due to time constraints. So we develop and demonstrate several scenarios as shown on the left of this slide, referring to the ICAO TBO concepts and FFI's manual. We assume various possible events which affect to the flight for each scenarios and identify issues to be solved and validate the TBO operations. So you can see some events, a significant weather, a special activity airspace, which leads to the required reroute, and airspace congestion, which leads to ATFM initiatives, sometimes ground delay programs, something like that. So, and on the other hand, a negotiation will occur due to improving conditions. So in the departure process, as I mentioned in the previous slide, agreed trajectory will be made in the FFI's process after confirming the acceptability of the flight by the relevant all facilities, the trajectory is shared and among them as an agreed trajectory. In the FFI's process, there are some optional services, such as trial services and planning services. But these are optional, but it's very effective and efficient way. So next slide, please. So the event of departure is a key factor of the TBO, since uncertainty decreases at this point. To achieve the TBO, to take into consideration managing uncertainty is as important as managing trajectory. As the flight approaches the planned departure time, the flight crew requests clearance to proceed. As I mentioned before the departure, there are still remain various uncertainties, such as passenger delay or additional fuel, and so on. Once the flight departs, the actual departure time is known and the agreed trajectory is updated and shared to reflect the actual time. Currently, we can't say that we have achieved this kind of information sharing, especially flight across several FIRs. So by that, downstream estimated time in this update trajectory are more accurate because the departure time uncertainty no longer applies. So next slide, please. So one of the significant benefits provided to the airspace users of TBO is the ability to request and engage in trajectory revisions during flight execution. It's a FFI Release 2 stage. When a flight is operating along a grid trajectory, the flight operator may determine that there is an optional need to modify, such as expedite or delayed. So in this case, the AU may request a revision of the agreed trajectory. You can see the picture and number 1 and number 2. As the AU formulates the request, the AU considers known information pertaining to the ATM configuration and system constraints. So the trigger of modification is not only originally AU's need, but also ATM configuration changes, such as sudden airspace restrictions or air route restrictions. The request should be formulated in such a manner as to not affect the agreed trajectory within the scope of the present separator and ATC separator. This allows the negotiation to occur outside the scope of the tactical actors. The AU may develop this through a combination of FOC and flight deck involvement. So you can see the conflict horizon in the picture below. So it's the extent to which hazards along the future trajectory of an aircraft are considered for separation provisions. So there are mixed tactical and strategic weight. Next slide, please. So I go back to the TBO demonstration again a little bit. So this is a sum of the post-departure conditions. So as I mentioned, there are a lot of uncertainty even in a in-flight situation, whether the volcanic ash, typhoon, special activities, runway configuration, also the demand capacity balancing. So there are some vignettes from the TBO demonstration. So you can see some events in the flights US to Japan. There are some DCB events in the beginning of the flight, and we have special activity airspace in the middle of the oceanic area, and also calculated time over events approaching the Narita airport. So we simulate something like that in a demonstration. Thank you. Next slide, please. So these are operational values I can describe here. So there are a lot of values here. Next slide, please. And further challenges are still there we have a long mixed model environment, both AU side, ASP side, and the trajectory negotiations between multiple ASPs and the scenarios of multiple flights and impact of tactical decisions on the strategic plan. So next slide, please. So thank you very much. This is my last slide. So TBO is not a one-size-fits-all solution. Regional priorities can be emphasized at TBO alignment with the global TBO concept. So it's time to start to explore the future operation in our APAC region together. Thank you very much. That's all.
Thank you, Yukio. Next up, we have Dr. Amorat. Amo is a strategic planning manager, engineering, specializing in new technologies and engineering systems for Aerotype. She's also a member of the technical subgroup under the Asia Pacific Cross-Border Multinodal ATFM collaboration. She is co-chair of the ICAO Asia Pacific SWIM Task Force and a member of the National Information Management Technical Working Group responsible for Thailand's SWIM planning and implementation. At the global level, she's a member of the ICAO Global Air Navigation Planning Study Group, responsible for developing global air navigation plan. In 2014 to 2016, she was the project lead of Aerotype's participation in the mini global demonstration led by FAA to showcase the possible global SWIM architecture. In 2017 to 2019, she was the project co-lead of the SWIM in ASEAN demonstration, which was successfully conducted in November of 2019 to demonstrate the principles of SWIM, and more importantly, a model of SWIM implementation for Asia Pacific region. Amo, you have the floor.
Thank you very much, Mr. So, for your kind introduction. And I also like to thank Council for providing me an opportunity to speak with you all today. My focus today will be on the technical enabler to support the TBO. Next slide, please. A bit of a recap of what both Tawai and Yukio mentioned previously. Central to the TBO is the sharing and managing and also using of trajectory information as a common plan for a flight. So if we are going to look for the technical enabler, the question that I would like to encourage you to ask yourself is, which technical capabilities would be required to enable the operation of such concepts? For me, I think we can divide these requirements into two groups. One is how we can share or better share the trajectory information. Another is how we can manage or better manage it. After that, we then can start thinking about what the technology choices we have to deliver those capabilities. However, due to the time limit we have today, I will not be able to go into the details of each technical enabler. Rather, I will only provide you their overviews. Next slide, please. As Tawai mentioned, information exchange is one of the important building blocks for the TBO. So to share the trajectory information, I think you would agree with me that the first thing that we need to do is to build a technical infrastructure or technical solution capable of providing the seamless and timely information exchange among aviation stakeholders, so that all stakeholders are aware of the latest trajectory and consequently and importantly can make a collaborative decision. In this regard, SWIM, which is considered as aviation intranet, can help us address that. Next slide, please. Also, as mentioned by Yukio in his presentation, that in the TBO environment, it is expected that the trajectory information will be shared for the whole phase of flight, and the airspace users will also play an important role in sharing this information. This can translate into the requirement that the aircraft needs to be connected to the information exchange platform or in other words, being a node in Stream. Combining the connectivity to aircraft stream with electronic flightback or EFB, the airspace user will be able to connect the flight deck to the information available via Stream, and with the leisure information, a customized application for analyzing or presenting information can be built for the flight crew. These all technologies will enable the flight deck to collaborate in trajectory negotiation with the TBO-capable ATM service provider. Next slide, please. As Tawai mentioned, there will be a change between the current ATM operation and the TBO operation. And this change we need many TBO capabilities to make this change happen, such as we need a capability to coordinate the trajectory information across global ATM operational concept components. We need a capability for the pre-departure and post-departure trajectory negotiation, or even the exchange of the trajectory parameter, for example, the airspace user's constraint or the airspace trajectory preference. And as mentioned by both Tawai and Yukio, FFIs will provide this change. With the information requirement for flight planning, flow management, and trajectory management defined in the FFI, a greater information exchange environment can be created with our ATM community, and to ensure the global harmonization. At the heart of the FFI is the development and application of global standards for information exchange, such as the use of flight information exchange model of FIXM for flight information, XM for aeronautical information, IREXM for information, and that needs to come together with the standards and recommended practice procedures as well as the guidance. Next slide, please. Another crucial aspect in TBO is how we can better synchronize the flight intent aircraft so that the greater precision in trajectory prediction can be achieved. This is when the surveillance technologies come into our picture. With the use of ADS-B out and also ADS-C, aircraft derived trajectory information, for example, position, altitude, and speed, can be made available for the ground system. The utilization of such surveillance technologies can help in monitoring the conformance against the agreed trajectory as well. At this point, I think some of you may argue with me that there are many options for surveillance system in the market, and we might not need to go and buy or install the ADS-B ground station. I would agree with that argument. However, they all come with different in accuracy, integrity, and information content. And I think with the difference in the performance of surveillance technologies, I think you would agree with me that these attributes will impact the accuracy of your trajectory prediction in the TBO environment. Next slide, please. Now let's move to another TBO capability we are looking for, how we can manage the agreed trajectory. From the operational perspective towards the TBO that Yukio walked us through, it can be imagined that TBO clearance would be more complex than the current air traffic control clearance. With its complexity, the communication of this TBO clearance through voice would certainly create an intensive workload for air traffic controllers. Data communication is thus required for the TBO. Through the use of CPDLC, TBO clearance can be provided through the flight deck and loaded into the flight management system or FMS on the aircraft for execution upon approval by the pilot. Use of data communication can also help ensure that both ground and aircraft automation systems are aware of clearances without relying on human input or intervention. If you combine this capability with the downlink aircraft intent, the quality of flight intent data contained in the ground automation can also be improved. And as I mentioned previously, FMS provides an ability to input TBO clearance sent through CPDLC to deliver the agreed trajectory. With the capability to send leisure data to the flight deck using data communication, more information on clearance limits can also be delivered to the aircraft. And in addition, flight-specific information such as defined procedures or constraints at the waypoint can also be processed by FMS, and the aircraft-derived trajectory information can then be computed using the aircraft current position. And this aircraft-derived trajectory can then be downlinked to the ground system for better flight intent synchronization air-ground as well. Next slide, please. Talking about clearance delivery, another aspect to consider is the application of performance-based communication, or PBC. With PBC standard, the delivery and acknowledgement of a clearance which affect a trajectory can be achieved with the integrity and timeliness requirements. Consideration on required communication performance for different service functions should also be given. For example, trajectory changes proposed as a result of pre-departure demand capacity balancing process can be communicated with lower PBC requirements compared to changes required by the conflict management. And for the PBN, as you may have heard also from Dawei and from our introduction video, PBN enables the aircraft to more accurately navigate along its trajectory. On the other hand, the performance-based surveillance, or PBS standard, provide us the surveillance performance characteristics necessary for managing aircraft position uncertainty, as well as conformance monitoring for determining trajectory updates. Next slide, please. The TBO capabilities you have heard from Dawei, Yukio, and also myself so far can be delivered through the combination of technical enablers I have been talking about. This table concludes the capabilities and corresponding technical enablers. A big show an enabler required to deliver the capability, while an up arrow shows an enabler that is useful for improving the performance of capability. So the up arrow is not a must, if you can consider it that way. You can see from the table that the top three combination of technical enablers for TBO capabilities are connected aircraft, FFI, and SWIM. However, the implementation of these technical enablers alone may not be enough to deliver the capability. The automation system enhancement as well as training to support the TBO processes are also required. Besides the operational models such as the participation of airlines flight operation centers in trajectory sharing and trajectory negotiation in the mixed mode TBO environment can also impact the achievable level of TBO capabilities. Next slide, please. As CANSO is an organization of air navigation service provider, after hearing all this information, I guess one of the very first questions you may ask is how your organization becomes TBO enabler. Here is a short list of criteria, and that includes first the ability to support trajectory negotiation in both pre-departure and post-departure phases. Second is the ability to create and deliver the TBO clearance. Next is the ability to use the aircraft-derived trajectory and also to provide a decision which integrates across the global ATM operational concept components. You also expect to be able to support the sharing, updating, and the revision of the agreed trajectory. And if there is a performance need, that also includes an ability to support the use of trajectory parameters provided by the airspace user, as well as capability to support the creation and delivery of precise clearance. Next slide, please. Just to give you some ideas from our experience on how we start our work to prepare ourselves to become the TBO-enabled ATM service provider. This figure shows part of Aerotype's TBO test bed. Basically, our first focus is to build a seamless information exchange infrastructure or the SWIM infrastructure, and we top it with the SFI capability, as well as the integration of ATFM modules and the traffic synchronization too. And within the scope of multi-regional TPO demonstration, we also enhance our test bed with cybersecurity services to ensure the end-to-end trusted information exchange among stakeholders. You may notice from this figure that some of the modules on our test bed are what we developed in the SWIM in ASEAN demonstration, while some are being developed right now under the multi-regional TPO demo. So I think one of the quick win solutions you may want to consider in starting your work on TPO is to utilize what you have from the previous successful demo that we conduct together 2 years ago. That's all I have for now. Thank you very much for your kind attention. Back to you, Mr. So.
Thank you, Dr. Amara. Well, next up we have Diana. Ms. Diana Liang comes from the FAA NextGen organization. Diana has successfully provided direction and oversight on the development and fielding of many of the FAA's NextGen programs and enabling technologies. As the NextGen Enterprise Portfolio Manager, she helps to prioritize all NextGen research and development activities within the FAA from a funding and schedule perspective to help the National Airspace System recognize many of the planned performance improvements. Ms. Liang is also the US nominated panel member of the ICAO Information Management Panel, working on SWIM and information management provisions, and a technical advisor to the ICAO ATM Requirements and Performance Panel, working on FFIs, connected aircraft, and TBO. Diana, you have the floor.
Thank you, Mr. So, and thank you, Council, for this opportunity to talk about TBO. Next slide, please. You heard from my colleagues about the TBO operations and technologies today. These are technologies needed to enable TBO. My focus, my presentation would be on the TBO demonstration that we're in the midst of doing. This is the timeline for TBO demonstration in 2022 and 2023 with some high-level milestones. February 2022 is when we're putting all our pieces together and conduct the demonstration. And then in 2023, we want to be able to fly a limited set of TBO capability to show that the future is not that far away. Next, please. Previous presenter, Yukio and others, has talked about the scenario that we would be demonstrating. And what I want to do is just briefly talk to you about the 5 scenarios that we're doing in our phase 2A. The scenario number 1 demonstrates multiple flights showcasing the sharing of trajectory information, negotiation, and update of information to downstream air navigation service providers. The importance of updated information for planning and operations for long-distance flights. In scenario number 2, we focus on the operations at the airport, at the arrival airport, and better information sharing early support the adjustment of the aircraft trajectories around constraints areas. Next slide, please. Scenario number 3 showcases long-distance flights in the Asia airspace and how information sharing can support multiple ANSPs to better accommodate changes to the operations and its impact downstream. And finally, scenario number 4 and 5 showcase the interoperability of information sharing and how to overcome some of the challenges in a mixed mode environment. Because we need to understand the mitigation measures, because not every ANSPs will be implementing all the TBO capabilities at the same time. Next slide, please. Once we completed phase 2A, we then move into phase 2B. We will apply the lessons learned and focus on the integration of the airspace users and their systems. Here, we will work with the airspace user to develop prototype applications to interface with the ANSP systems, developing operating procedures, test system interfaces, conduct safety assessment, and conduct flights to collect data and additional lessons learned. Next slide, please. Which takes us to the topic of what we hope to achieve in this demonstration. Laboratory activities and demonstrations is a safe environment to try these concepts and learn from each other by doing. The aviation network must be interoperable and performance-based. This is an important key here because this allows for some flexibility and alternative technical solution to best meet your constraints and needs. And from these types of demonstration, we can provide feedback to the various standard bodies to incorporate what we've learned into their work, and such as which most of my colleagues has identified here, the ICAO Global Air Navigation Plan, regional implementation roadmaps and plans, ATMRPP for the FFI's concept and the TBO concept, information management panel on SWIM and information management, and the communication panels for what the communication links to support both voice and digital transmission of information. Next slide, please. To recap some of the important points on TBO, information and data sharing is one of the key components. As you can see, some of the TBO capability listed here are driven by information that reside with different stakeholders and can be made better with information sharing among the stakeholders. Next slide, please. Information sharing is at the right time to enable TBO in Asia. TBO is to move toward more strategic decision-making, as you heard from the previous speakers. Technical focus is on the information management and exchange of information to support decision-making. And then successful information sharing is important. To deliver this TBO capability, we do need to put our energy in the area of information management and information exchange. The demonstration scenario showcased decision-making among multiple ANSPs and how it can be done while respecting each other's airspace sovereignty. Next slide, please. So in conclusion, implement TBO capability best meet your need, what your environment need is. We have said several times that TBO is not a one-size-fits-all. So pick the capability that best meet the airspace that you are living in and the policy that you're dealing with. What is not said in the various and learn from the various demonstration is that policies, robust regional policy for information sharing is important in order to make all these things happen. Technology can only go so far if we don't have the policy for data sharing, for transparency, governance of the data. And then finally, we have learned from previous demonstration that the foundation for TBO includes SWIM, include information exchange and management, the implementation of FFIs, and then finally to include cybersecurity in your plan and implementations. Next slide, please. And that concludes my presentation on the TBO demonstration. Back to you, Mr. So.
Thank you, Diana. We have set aside about half an hour for some discussion and to address the questions from the audience. I must say we are getting quite a deluge of questions, which is a good sign. I mean, it shows that people are really interested in the topic. And some of the questions, I must say, are fairly technical as well. Perhaps I can pose the first question to Dr. Amorat. Which is on data link. Quite a number of questions came from the audience on data link communications. Basically, well, I'll try to paraphrase and merge the number of questions together. Basically, how is the data link requirement for comms between pilot and the flight deck in the TBO world? How is that comms requirement different from today? Is, for instance, the CPDLC today between pilot and controller, or the FANS 1.8 over ACARS adequate, especially for the high density operations environment?
I would answer this question in two separate matters of information sharing. The first part would be about the clearance delivery, and that I was talking about the use of comm service called CPDLC. I would think that for the CPDLC with the complex TBO clearance, we probably would need to move from ATN-B1 to ATN-B2 in the transition phase for delivery of more complex clearance in the TBO environment. The second part that I would like to answer is about how we can exchange aircraft-derived trajectory information or the information that we have on the aircraft to the ground system. As Diana mentioned, that will assist the better decision making among the aviation stakeholders. We need to do information management and exchange together. That part, I would think that ATN-B2 might not be the answer. We might need to think about having the ATN based on the IP or the internet protocol, internet network protocol suite for that case. So I would say that for the CPDLC, you may think of the use of ATN-B2 in the complex aspect. And for the exchange of aircraft-derived information, I then think we need to prepare for the ATN-IPS.
Okay, thank you, Amor. Does the rest of the panel have anything to add to that? If not, we can move to the second question. I mean, there's quite a number of questions to go through. Second question is on TBO for manned and unmanned aircraft. Perhaps I can direct that to Diana. Basically, to summarize, I won't read every word from the question verbatim, but basically the question concerns, is there a difference between TBO for manned and unmanned aircraft? Because the other big development apart from TBO in the aviation world is, of course, unmanned aircraft. And the question is, could we perhaps develop TBO as a concept for unmanned aircraft and use that as a test bed to fine tune and for manned aircraft? Or so is there a big difference between manned and unmanned aircraft TBO? Diana?
Thank you, Mr. So. That's an interesting question, in which we are in the US FAA, we're looking at. Trajectory-based operations, when we talk about it at the FAA or even at ICAO, is trajectory-based operations. And it should not be different for manned versus unmanned. But we recognize that there are differences in how it gets, in terms of the technology needed to support the information sharing, for example, and then the negotiations process that we identify for the TBO. So I think that there's an opportunity to utilize the unmanned aircraft or the unmanned platform to test out some alternatives technologies that may be used that can then be transferred back over to the manned. The unmanned are smaller vehicles. They have the opportunity to be equipped with the newer technologies and lighter technologies. So what we learn there for communication, for surveillance, etc., is a good thing to see if the new technology can meet the needs, performance needs that we need to operate, and then could potentially transfer back over to the manned aircraft.
Thank you. The rest of the panel members, anybody wants to add to that?
Can I add something on that?
So, yeah.
Yeah, I do agree with Diana that the nature of these two types of vehicles a bit different, and the speed of technology development in unmanned aircraft is probably much faster than what we did or doing in our manned aircraft. But I would like to ask the fallback the question to think about that by the end of the day, if you check the global ATM operational concept document that Tawai mentioned in the beginning of his presentation, we are looking for the performance-based air navigation system for every type of airspace user. So it's not only about the manned vehicle, but it's also about the unmanned vehicle that they are going to run in the same air navigation ecosystem. So I think TBO to me is kind of a tool to achieve the performance-based air navigation. And that should also include the consideration of unmanned aircraft, and we can learn from each other.
Okay, thank you. Anybody else? If not, we move on to another cluster of questions, which is, I would call it a human factors question. A number of questions on the human factors. One is, how would you, well, I am posed that to UQ, since you're such an experienced controller. How would you see the role of air traffic controller evolving with TBO as the main operational concept? A related question is also from the pilot community, whether when we implement TBO, especially mixed mode environment, would that increase the workload for airlines and pilots?
Thank you very much for the question. Yes, I think we are now try to simulate and demonstrate this kind of the issues to be solved in the future. So in the multi-regional TBO demonstration of phase 2, we put the new scenario, which is including the ATC tactical intervention and strategic FFI's operations. So there is some horizon, conflict horizon, and a negotiation horizon, or a coordination horizon, 3 horizons. And so we are still under consideration. And I think it might be varied. It might vary depending on the regional requirements, but I'm not sure yet. And but I can say that that the workload of ATC wouldn't increase more than the current situation. So we shared, agreed the trajectory, all stakeholders, including ATC controllers. And so we follow the agreed trajectory, and I imagine, hopefully, the ATC workload and intervention will decrease in the future. That's all. Thank you.
But UQ, while we still have the floor, there's also another question specifically directed at your presentation on the conflict horizon. If I may read that out to you, what is the minimum time or distance away do you allow aircraft to go through trajectory negotiation? For instance, can an aircraft still negotiate if it's 10 minutes away or 50 nautical miles away?
As well as I recognized, since I joined the demonstration, in my recognition, it's not determined yet. it's still under consideration. Yeah, it's yeah, that's all. I can't say that.
All right, okay, thank you. Okay, next question is on why PBN is included as a key element. I think that came from Tewei's presentation when you mentioned the key elements, and PBN is one of them. The question is, can an aircraft not operate in a TBO style by using a trajectory that follows a conventional ETS route? You know, why or why not? And if not, does that mean that an airspace that can only be considered TBO capable if it's exclusive PBN airspace?
Thank you, Mr. So, for the question. So I think, okay, so we mentioned earlier for TBO, okay, so one of the common reference is trajectory. Okay, and one of the key elements for trajectory is actually time that we use to define trajectory. So in this case, I would say PBN is a very important factor because PBN helps to ensure more accurate and precise trajectory, which in turn allows for greater predictability and reduce the uncertainty. So all these are actually the key elements to enable TBO. Okay, so we have stakeholders, if they know about the plan, even if there's a delay, they can actually replan and know, okay, let's say I know that this aircraft will be delayed. Can I slot another aircraft in to actually fill up the gap? And this will improve the overall efficiency. Instead of, let's say, if we are talking about a conventional route, you may not be exactly sure of the time that he will arrive at a certain point, and you cause this gap to be missed up for another aircraft who could have taken it. Yeah, so I'll say in this case, the PBN is one of the very important factor for it. Thank you.
Thank you. Next question is a fairly technical one. Perhaps Amor can help us with this. Does TBO take into consideration degradation of aircraft equipment, such as a figure of merit less than 7 in ADS-C?
For now, I haven't heard about that we consider a specific performance parameter of specific surveillance technology for the use in the TBO. But one thing I can offer, if we're talking about the figure of merit for the ADS-C, it would be what it will play a role would be in the precision of trajectory prediction among the stakeholders that related to that trajectory. In the case that the figure of merit will be lower than 6 or 7. That's what I would say. What it will affect is the precision of trajectory prediction, not for the air traffic control itself.
Okay. Does the rest have anything to add? All right. Okay. I'm scrolling through lots of questions coming. Okay. This is directed at Diana. Okay. I'll try to read out the question. You mentioned that one important success for TBO would be about information management and information sharing. How do you envisage for decision making on shared information? Which framework are you considering for CDM? Diana?
Thank you. In terms of information sharing and information management, my colleague has pointed out the information exchange should be adherent to the established global standards or protocol for information exchange. Information sharing helps make the decision better, and that's in the area that we touch on with FFIs. FFIs allows the exchange of information about the intent, about the plan of what that aircraft wants to do and what the ANSP can accommodate through the negotiation process. So without the information sharing, we would not be able to do collaborative decision making through, and we would not be able to then execute some of the FFI's capabilities.
All right. Okay. Thank you, Diana. Well, I'll open the next question. All the members on the panel. Well, kind of combine a few questions together. does TBO have a global deadline time frame for the state ENSP or related stakeholders to implement? I guess the other related question would be, what does the panel think is the most probable showstopper or cause of delay for TBO realization? I'm open to anybody. Diana, please go ahead.
I think looking at it, and because I work on the ICAO panels, there's uncertainties of what is TBO, what is SWIM, what is FFIs. I think that if we are able to demystify that, that's one. The second thing is TBO is, as my colleague said, it's not a one-size-fits-all. And if we start to break the TBO into its components and only utilize the component necessary or that is applicable to the environment in which you operate in an environment or the airspace you operate in, will help take away some of the concerns that this might be too big and therefore you can't even get going on that. So that to me is the first big obstacle that we have to overcome, is the education of what some of these things are and make it into smaller bite size so that people, and hopefully it's pick and choose the things that is necessary for your environment, for your airspace, and that would then help make progress.
Anybody else?
I add something more. Yeah, I do agree with what Diana mentioned, and also based on Diana's presentation, you were giving the highlight to the information exchange, the regional policy for information management and stuff. One thing that I think can be showstopper, a very first showstopper for the TBO, if we do not start working together, how we can exchange our information seamlessly and in a timely manner. Asia Pacific already started. We all agree that we are going to have the CLB as our common backbone network for the region. But we could not only stop at the CLB, right? We need to also continue further, trying to implement SWIM on top of that. And then we can start exchanging information concerning to our operation. We are not asking all of you to dump a huge amount of data or information you have onto SWIM in our regional SWIM, but at least the part of information that will benefit your operation, your airspace user, and also your neighbor. I think that could be a start point. If we're still reluctant with sharing our information out, I mean in automatic manner, I think that could be a showstopper for the TBO to start initiating in the region.
Anybody else?
Sorry.
Go ahead.
Yeah, just to add something. So after the presentation, you will realize that actually TBO is actually a very huge paradigm shift in operating mode. So as they say, Rome wasn't built one day. Okay, we cannot really imagine TBO to be ready just immediately like that. There's a lot of procedures, processes, technology, people, and harmonization, as mentioned by other panelists. Okay, so I think the approach is very important. Okay, in this, I believe that this current situation of COVID, okay, it actually gives us a window of opportunity to actually work on such concepts. So I think this is a good time that we can actually to joining this MRTPO, okay, we actually able to demonstrate and visualize possibilities, okay, and share lessons learned. I think this is a time that it is important that we can get together and explore such concepts. And once we get more stakeholders on board, then the eventual TBO can be realized once we all get together. Thank you.
Yukio, anything to add to that?
Yes, thank you. I think the SWIM and FFI's release one is the first step to realize the TBO operation. So I think that in our region, we need to more facilitate the FFI's release one acknowledgement and understanding, and also at the same time, we developed the basement of the SWIM information exchange framework. So that's I think that's an important factor for the TBO. Thank you.
All right, thank you. I think we have time for just one last question. This question is on long-range ATFM. You know, some council members are experimenting with long-range ATFM. This requires ANSPs to coordinate flight information with airline flight ops center. TBO as a concept would tightly link flight deck, flight ops center, ATFM, ATC. Is long-range ATFM then a building block towards TBO? Is there room to kind of like combine long-range ATFM trial with the future TBO trials? Anybody? It's open to anybody.
I think, okay, let me try.
Yeah, you're familiar with lots of the ATFM work.
Yeah, I think in my idea, I think the long range ATFM would be integrated as part of the TBO, not a building block for a TBO, not like the FFI. I think to me, long range ATFM is another type, is another category of ATFM. I mean, with the longer distance, right? With the longer horizontal that we are looking at. So what I would imagine is the long range ATFM will be integrated probably in the FFI release too, where we have the post-departure trajectory negotiation. And then for example, the air traffic flow management unit may propose ATFM measure that affecting a flight that already en route. And that flight might need to go to the FF5 release to trajectory negotiations to get the agreed trajectory with all the ATM service provider that flight is flying through. I would see it as an integral part, but not a building block for the TBO. I'm not sure if Yukio would agree on that.
Yeah, but thank you, Ramo. I think I feel the same way as you. So I think in the future, a long-range ATFM needs more distance, long range, because it's a long range. So it needs more time beforehand. And so it's suitable for the FFI's R2 execution procedure. So I think it's combined with FFIs and R2, and but it's an ATFM measure, so it's not a tactical ATC. So we have to be careful about traffic synchronization and demand capacity balancing. So ATC will be the side of the TS, traffic synchronization, I think. So we need separate properly between ATC and DCB or the FFIs R2 encoding that. So that's all. Thank you.
Anybody else?
So,
wait,
if I could just add, yeah, actually, so as they mentioned, long-range ATFM would actually, I think one of the other important factor is that it will actually cover a lot of ANSPs. Okay, most of the long-haul routes you will cross through many FIRs and all that. So as our panelists also mentioned earlier on, FFI's element TBO, it will be implemented in the mixed mode environment, which Diana mentioned. Okay, so I think it's also important to recognize that it may not be that easy to actually implement long-range ATF into this whole concept, because you will definitely have to do it in the mixed mode environment in this case. Yeah, thank you.
All right. Thank you, everyone. I think to bring this session to a close in view of the time. So today we have learned a lot from our 4 speakers. I want to extend a big thank you to Diana, Amor, Yukio, and Dewey. I hope our audience have found this session to be beneficial as well. For those of you already on this transformation journey, there's still a long way to go. For those who have not started, this is the time to start. We can start this journey with small steps. Start asking our engineers, how can our comms systems be ready for SWIM? Start asking our vendors, how can our ATM automation system be ready for FFIs, the new flight plan format? We want to know, and we need to start now. If we do not have all the answers, do not fret. Get involved in some of the trials, some of the discussions, be it TBO or SWIM or I4D, even as observers. Those who have the answers are very keen to share them because the benefits of TBO are multiplied as the number of adopters increases. TBO is a cross-border, cross-organization capability. Perhaps ANSP may even want to start setting up an internal task force on TBO within your organization. TBO is complex enough to warrant a task force. Then you will have a core team who will look for the answers, that's required. As some of you may know, the CANSO Asia Pacific Ops Work Group is meeting in November. We will be having a mini workshop on I4D. So let me assure you that we are continuing this conversation on TBO. This is an exciting journey. Let us enjoy the ride. Have a good day, everyone. Thank you.